As you have learned in lower classes that 2 points are sufficient to determine a line. That is, there is one and only one line passing through 2 points. Now, a natural question arises. How many points are sufficient to determine a circle? Take a point P1. How many circles can be drawn through this point? We can see in the figure that an infinite number of circles can be drawn through P1. Now take 2 points P2 and P3. Again we can see there may be an infinite number of circles passing through P2 and P3. What will happen when you take 3 points? We will consider 2 cases. When all the 3 points lie on the same line, that is when they are collinear, and the another case when the points are not lying on the same line, that is non-collinear. Let's see the case 1, considering 3 collinear points. If we try to draw a circle passing through 3 collinear points, one can see that the third point will lie outside or inside the circle. So we can draw a circle touching all the 3 collinear points. Now coming to the case 2, if we consider 3 non-collinear points, just take 3 non-collinear points like P7, P8, P9. Try to draw a circle touching all the points given. What is your result? You will notice that only one circle can be drawn using 3 non-collinear points. And it is stated in the form of a theorem. Let's see the proof. Theorem number 7. Theorem statement. There is one and only one circle passing through 3 given non-collinear points. Given P, Q, R are the 3 non-collinear points, and we need to prove only one circle passes through these points, that is P, Q and R. Coming to the construction part, draw AB, perpendicular bisector of PQ at M, and CD, the perpendicular bisector of QR at N. Coming to the proof part, PQR are non-collinear. It's a given data. PQ is not parallel to QR. AB and CD are also not parallel. Also, we have to see that AB and CD have to intersect at a point. Let that point be O. Now, join OP, OQ and OR. Consider triangle OPM and triangle OQM. You can refer the figure 1. You can see that OM is equal to OM, it is a common side. Now, angle OMP is equal to angle OMQ. What is the reason? Both are 90 degree because AB is perpendicular to PQ. Now, PM is equal to QM. What is the reason? AB bisects PQ. Therefore, triangle OPM is congruent to triangle OQM by SAS rule, side angle side. So by CPCT, we can say OP is equal to OQ. Mark it as equation number 1. Similarly, the same way, we can write OQ is equal to OR. Mark it as equation number 2. Now, from equation number 1 and equation number 2, we can write OP is equal to OQ is equal to OR. Let OP equal to OQ equal to OR equal to, let it be R. Now, taking O as center and R as radius, construct a circle. Now refer the figure 2. Hence, circle passes through the points P, Q and R. Hence, the points are concyclic. Now, we have to prove that there is only one circle. Let us assume there is another circle with center O dash and radius R dash passing through P, Q and R. Let us draw a perpendicular from O dash to PQ at M dash, that is OM dash is now perpendicular to PQ. Now refer the figure 3. Now also PM dash is equal to QM dash. What is the reason? Perpendicular from center to a chord bisects it, right? Now M dash is the midpoint of PQ, which implies O dash M dash is the perpendicular bisector of PQ. But OM is the perpendicular bisector of PQ. As a line can have only one perpendicular bisector, OM dash coincides with OM, or we can say O dash coincides with O. Hence, only one such circle exists that passes through the points P, Q and R. Hence, proved. Also, you have to note, if ABC is a triangle, then by theorem 7, we know there is a unit circle passes through three vertices of the triangle A, B and C. This circle is called the circumcircle of the triangle ABC, and its center is called the circumcenter. Its radius is called the circumradius of the triangle. Okay, now let's have a recap of what we have learned in this section. This section was an answer to the question of how many points were sufficient to determine a circle. We have three cases considering 1 point, 2 points and 3 points. Taking 1 point, we have seen that infinite number of circles can be drawn. Taking 2 points, again we have seen that infinite number of circles can be drawn. Taking 3 points, again we have two cases, that is with 3 collinear points, we have seen no circle can be drawn touching all 3 points. With 3 non-collinear points, we have seen only one circle passes touching all the 3 non-collinear points.